Bill here. I'm going to talk about something a little bit different. We're still talking about linked lists. I want to talk about a sorted linked list. And what I mean is why don't we suppose that our nodes, they're pretty simple. There's a name in here, and then it points somewhere else. And I want to assume that we keep it sorted. So maybe we've got something that looks like this. And the idea here now is I want to come along and I have a new node here. My new node is Frank. I want to insert it into this list. So it's obvious that Frank is going to go here. And I think what is also obvious is that I'm going to have some variable called Rover that's going to keep checking. Okay, as long as this name is less than Frank, I advance Rover. This name is less than Frank, I advance Rover. This name isn't less than Frank, so it's time to insert. But the problem is, again, like we did with delete, I'm going to need access to this reference right over here. And you can see that basically what's going to happen here is I am going to need two variables. I'm going to need one called prev, which will stay one before Rover. And as I iterate through the list, okay, I set prev to Rover, and then Rover is equal to Rover.get next. Okay, so we can imagine the following here. And again, I'm just sort of thinking out loud for a moment, and I'm going to say something like the following. I'm going to say while Rover doesn't equal null, and Rover.getName, and I think I'm going to run out of space here. Rover.getName dot compare to. All right, this isn't working out well. Let me see if I can erase this. I'm going to leave this over here. And I'm going to make my stylus a little bit thinner. Maybe that'll help me get this out of the way. And we'll get another one of these over here. So again, what I'm thinking about here where Rover doesn't equal null, and Rover.getName dot compare to, and let's suppose it's key. Some key has come in here. While that's less than 0. Okay, so think about what we're doing here. First of all, I'm using Java's short circuit abilities here. Notice I've got an AND here, and logically I could put this over on the right side and put this over on the left side. But I'm using the fact that Java short circuits things. And what that means is that I may ultimately go off the end of the list and Rover may become null. If Rover became null and I executed this, I would get a null pointer exception. So I put this first so it guards so that if I make it over to this expression over here, then that means Rover is not null. And basically what I want to do in this situation over here is I want prev to equal null, or no, I'm sorry, I want prev to equal Rover, making a lot of mistakes here today. And I want Rover to equal rover.getNext. And this is inside of a loop. Okay? So, in my mind, I can think of several situations, and I want to draw some pictures here. So in one situation, front is just null. I've got an empty list. In another situation, maybe I've got a list that looks like this. And there's maybe this is Bob, and I want to insert a node that has Al in it. So in other words, the idea being I want to insert this before the beginning of the list. Another situation I can think of is maybe I have something that looks like this. Maybe this is Sam. And I want to insert Tom. So I have an empty list, inserting at the beginning of the list, inserting at the end of the list, and then there's just the regular old one where I'm inserting in the middle. Okay. Now if I'm inserting in the middle, remember what's going on is I am Rover may be pointing over there. Prev is pointing over there. And I have some new node over here that I want to insert. And I think we can see what the code would be. Basically what I want to do is I want to do the new node dot set next to Rover. So I'm going to come over here and I'm going to say new node dot set next to Rover, and then I'm going to say prev dot, let's think about that. If I were to say new node dot set next to Rover, that's going to update this pointer here to come up there. And then what I want to do is I want to do a prev dot set next to new node. Okay, and I'm going to guess that initially up here I am going to probably set previous equal to null, and I am going to set Rover equal to front. Now let's go back to our picture. Now this picture over here, this corresponds to front equals null, and we also have prev is equal to null. Okay. I wish I could make the screen a little bigger. But I want to consider these cases right over here, these different pictures. And the first thing is I think that the code that I have written so far, well, this is the regular case where I'm inserting in the middle of a list. So I think that we've taken care of this one here. But now the question is have I taken care of this situation over here? Well, let's go back and look at the code. If I go back and look at the code, we're talking about the fact that Rover is run off the end of the list. So Rover is run off the end of the list, but prev hasn't. Okay? And if I make it over to here, remember, if I'm inserting a new node at the end of the list, the new node, in fact, its next pointer, it should, in fact, be null. So if Rover is null, new node dot set next to rover in that situation is fine. I'm setting it to null. Previous dot set next new node, that's absolutely fine. In other words, what I'm saying is that this code that I have written here is absolutely fine in this case as well. Okay? And remember, this is the case where I'm going off the end. So the only thing I have to worry about are these two cases here. So this case over here is previous is equal to null and front is equal to null. And in this case over here, previous is equal to null and front doesn't equal null. Okay, but it is the case that the new node that we want to insert is less than that. Okay? Is that going to work? Is the code that I've written here work? Will it work for this situation over here? Well, no, I don't think it's going to, because I've got this problem over here. Okay? While rover doesn't equal null, let's think about this, and rover.getName.compareTo is less than 0. Well, that's not going to be the case. It's going to jump out of this loop right here. Now, what we want to do is does new node.setNext equal rover? This line would be fine, but this line over here isn't fine. Okay? So basically what I need to do over here is I could do the following. I could replace that line and say if previous doesn't equal null, then do previous dot set next to new node, else what? Well, remember what's going on over here. Okay, I'm inserting up here. I've got to reassign front. So replace this line over here with this line over here. Okay? And what we've done now is we've now taken care of this case over here. And now I say, well, why don't we just take care of this right up top? So I know I have not written this code well. I'm going to really do a cheat here. I'm going to come over here and say File, New. I'm going to do it this way. So I would come over here and I would say something like the following. If the front is equal to null, let front equal new node. Else do this. You could think about that, put in there. Okay, and I do apologize. I should have somehow figured out some way to get this all on the screen. And then I'd have to close it up. So this code that you're seeing over here would be inside of here. Okay? The point is that these algorithms get developed, okay, by drawing these pictures and considering all the cases. Okay? Maybe what I'll do to make this a little bit neater is I will type this up. Okay, here's a cleaned up version. So we have public void insert sort. So this is again a linked list. We're coming in with a node. Notice the first thing I do over here, I just do this for convenience. I grab the actual string key out of it. I declare these two nodes here. I initialize rover to front and previous to null. Okay, so here I check to see if it's the empty list. If it's the empty list, then I just set front equal to the new node. I'm all done. Else, and here's where I go into my while loop. Okay, and we talked previously about how this while loop works. Once I exit the while loop, okay, I am going to set new node that's set next to rover. Okay, now here, if previous doesn't equal null, that means we're inserting in the middle or the end of the list. Okay, and I do a previous.set next to new node. Else, here I'm inserting at the front of the list, and I have to set front to new node. This takes care of all of the pictures that we drew, wherever they may be. They're right over here. Okay, the first case, just an empty list. That's taken care of right over here. These three cases, well, we go through this loop, okay? Over here, we check to see if we're inserting through the middle or the end of the loop. That takes care of these two cases right over here. Otherwise, we're inserting at the front. That's this case right over here. Nice. Took a while to figure this out, but I think it was well worth the effort. All right, I'm going to show you one more thing. Okay, now what I just showed you now, whoops, cancel. There we go. I just showed you sorted linked list, and I'm going to call that hard. Now I'm going to come back and I'm going to say sorted linked list. I'm going to call it easy. Okay, and here's the easy sorted linked list. The easy sorted linked list, consider the following. Our empty list looks like that. But instead of it looking like that, what if our empty list looked like this? And what I want to do is I want to put a value in here that will be less than anything I could ever possibly insert. And I want to put a value in here that is greater than anything I could possibly insert. Well, again, remember, we're talking about sticking strings in there. I'm grabbing my keyboard because I need to go do an internet search. And you'll see why in a moment. And I'm going to come over here and I'm going to say ASCII table. And there's the ASCII table. That's not in an easy form. Let's find a better ASCII table in here. Let's try that one. Now, I don't know if you can all see that. That's probably not easy to see, is it? But notice I come over here. Here's the ASCII A, and that corresponds to the number 65. There are lots of things I could pick that are smaller than that. For example, if I picked a 0, that's a decimal 48. That's pretty small. Oh, here's a good one right over here. How about space? Space is an ASCII 32. And if I get below space, I'm down here at all sorts of control characters. Now, I could be clever and just use an ASCII 0. But space looks pretty small. And then if I want to go the other way, oh, look at that tilde over here. That's way up high on the ASCII table. That's 126. So I'm going to come over here, and what I'm going to put here, I'm going to put a string of a bunch of spaces. I don't care how many, 5 or 6. That's fine. Okay, there are a bunch of spaces in here. And what I'm going to do over here, I'm going to put a bunch of tildes here. And those are tildes in case you can't tell. I'll close that up like that. Okay. And now what happens, so if my constructor makes the initial list look like this, then whenever I come along with any sort of new node, I'm really having, that's why I'm having trouble. I need my tablet back. Whenever I'm coming along and I'm inserting some new node, so here's a new node with Bob in it, or here's a new node with Alice in it, or here's a new node with Tom. These are all going to get inserted in the middle. Okay? I don't have to worry about those goofy cases. I don't have to worry about the linked list ever being empty. I don't ever have to worry about the case where I'm inserting before the first node. I don't ever have to worry about the case where I'm inserting after the last node. Quite simply, I'm just always going to execute this simple while loop right in here. And I'm going to do this new node.setNextRover. And then over here, I don't even have to worry about this part. I just need to say previous.setNext to new node. I can get rid of all of this code up here where I'm worried about the empty list. In other words, what's going to happen here is that the insertion routine gets much, much simpler. The only thing you have to remember is if you ever have a routine where you're printing out the linked list, you don't want to print out this one here, you don't want to print out that one there. But you're using these are sometimes what are referred to as sentinel values. And for those of you out there that might be in the armed services, you realize a sentinel is a signal. It's somebody that is standing somewhere in the road and they're indicating that the redcoats are on the other side of the trees or something like that. These two sentinels here are indicating the beginning and the end of the list. We always want them there. We're always inserting in the middle. Makes life easy.